Okay, so note 7 is going to be factoring trinomials. So we're still factoring trinomials like we did yesterday, but now you're going to notice that our a values are going to be different numbers. They're not just going to be 1. Okay. And let's see if I do rewrite note. Okay. So this says factoring trinomials by the AC method. Another way, and the most common way they refer to it in college algebra, is a factor by grouping. So you may hear it both ways. AC method, the reason why they call it the AC method is when we're going through the process, you're going to notice that one of our first steps are going to be multiplying A times C. But you might also hear it referred to as factor by grouping. Okay. So here are the steps written out for those of you who like to see that visual of the written steps. Okay, I'm going to be going through all these steps on the problems. So for me, I'm more visual in the way of example, so it makes more sense to explain the steps through the examples. Okay, so again, our first step is to always make sure that our trinomial is in the correct order. So what that means is I should have x squared, then x, then my number, which I have here. And then I go through and I label everything A, B, C. So what would be my A value?
2x squared.
Just the 2, right? Remember, A, B, and C are just going to be numbers. Okay, we're not going to carry our variables with it. So then what is B?
7.
And then C? 6. So then our first step here is going to be multiplying A times C. So off to the side, I'm going to do A times C. Okay, and we're making the same chart as we did yesterday. But instead of just saying, okay, 2 numbers that multiply to C and add to B, we're now saying 2 numbers that multiply to A times C and add to B. So looking at A and C, that's 2 and 6. What's 2 times 6? 12. So we need 2 numbers that multiply to 12 but add to 7. Okay. And then remember, if we can't think of what those factors may be in the beginning, we just list all the factors. So we do 1 times 12, 2 times 6, and 3 times 4. So which of these, if I were to add them, would give me 7? 3 and 4. Okay, so 3 plus 4 gives me 7. So I know I'm using 3 and 4. So now what I'm going to do, instead of going straight to my parentheses like I did yesterday, I have to expand that middle term. And instead of writing 7x, I'm going to write 3x plus 4x. Okay, so 2x squared, so that first term comes down. And then the order doesn't really matter, but it can be helpful to put common numbers together. So for example, would it be more helpful to put the 3 with the 2x or the 4? Right, if we want the common numbers together, 4. So I would do plus 4x plus 3x plus 6. Okay, so I'm still using these terms that I found, the 3 and the 4. And we said that 3 and 4, if I add them together, I get 7. So what I'm doing in this step is just expanding that middle term. And the reason that I'm doing this is when I have 4 terms, I'm now able to group them like I did before. So remember on the notes when we talked about GCF and grouping the numbers, we said we can look at the first 2 pairs and draw parentheses around them, and then the second 2 and draw parentheses around them. So that's what we're going to do. So it's bringing it back to a couple notes ago when we talked about GCF. Okay. So then from here, all I have to do is take the GCF out of each of the parentheses. So looking at the first parenthesis, what can I take out of 2x? Good, I can take out a 2x. And when I do that, remember I divide each term to get what's left over. So 2 divided by 2 is 1. I don't have to write the 1. And then I started with 2 x's and I'm taking away one of their x's. So how many do I have left? Just one x, right? So I just write x. And then I do, good, plus 2 because I do 4 divided by 2, which is 2. And then x, take away an x, those x's are now gone. Okay. And then I go to the next parenthesis. And then I'm going to take out a GCF from there. What GCF can I take from 3x plus 6? 3. So when I take out a 3, what am I left with?
X plus 3. Wait, 2.
X plus 2. Good. So then remember when we started talking about dividing out polynomials, factoring out those those binomials. We said we know we're doing our math correct if these parentheses are exactly the same. Okay, so since they are the same, I'm going to write them one time. So that's me taking out the GCF of x plus 2. And then what do I have left over? 2x plus 3. This is my answer. Okay, so a few more steps than yesterday's factoring. Okay. What's nice about this method, the factor by grouping, is that this method will work every time. So if you want to use this method on the notes we did yesterday, and you're just using 1 for A, you could still go through this whole process. Okay, split up the middle term and then do the factor by grouping.
4x and 3x. If you switch.
So if you switch, what you're gonna notice is, and let's go ahead and show that. I'll show that one. So let's say we switched 3x and 4x. Okay, you're gonna find out that you're gonna get the same answer, but it just makes it easier for us to pair the numbers together. So for example, if I had 2x squared plus 3x plus 4x plus 6, I would still separate them with the 2 parentheses and still take out a GCF. So let's say we do it this way. What would the GCF of the first parenthesis be? Not 2x anymore because 2 and 3, we can't take out a common number.
X.
Just x. So if I take out an x, I'm left with 2x plus 3. And then what can I take out of 4x plus 6?
4, 2.
A 2, right? Because 6 and 4 can both take out a 2. And then I'm left with 2x plus 3. Okay, do my parentheses match? Yep, so I did my math correct. These match. And so I would take one out, and I have the 2x plus 3. And then what's left over on the outside? X plus 2. So this is just to show you that it doesn't matter if you switch the numbers that we get.
So the best way to go with the highest number.
I think for me personally, the best to go is think of what number is here and then decide what number to put first. So since this was an even number, it made sense to put an even number here. To me, but it can be, it can work either way for any type of, how you're doing. Yes. For me, I think it's easier. Yes. Oops. Okay. But again, both of these are the correct answer because the order doesn't matter. Okay, so let's look at the next example. Okay, so remember our first step is to label A, B, and C. So what is A? Is it 2 or is it 2x squared? 2. It's always just the number 2. Okay, and then what's B? 5. And then C? 3. Okay, once we label them, then we multiply which 2? 2 and 3 are A and our C. So we do 2 times 3, which is 6. And then we take our B value, which is 5. So this is our A times C, and this is our B. Okay. Then we look at all the factors of 6. We have 1 times 6 and 2 times 3. Which of these, if I was to add them together, would give me 5? 2 and 3. Okay, so I know I'm using 2 and 3. Okay. So then when I'm rewriting this, I write 2x squared plus 2x plus 3x plus 3. Okay, this middle term should always match this middle term, like if we were to simplify it. Okay. So I found my 2 factors. I split up the B value. What's my next step? Separate them into parentheses. And then do what?
Expand.
The GCF. So when we take the GCF, we are, yes, dividing each of the terms. So what would the GCF of the first parentheses be? 2x, good. So if I take out a 2x, what would I be left with?
X plus 1.
Good, x plus 1, right? This is a 2x, and if we divide that by 2x, these values cancel out, and we're left with just 1. Okay. Okay, what about the next GCF? 3, and we also know it's 3 because what should the parenthesis look like? X plus 1. So we take out a 3, and we're left with x plus 1. Okay, our parentheses match, so we did our math good. So then I bring down one of those parentheses, and then what's the next parenthesis?
2x plus 3.
2x plus 3, that's our answer. Again, this is factor by grouping. Okay. Let's see another one. Okay, then we get an example like this, which means we have to do what first? Switch it around. Because is it in the correct order? No, it needs to have the x squared first. So I'm going to make 8x squared minus 2x minus 3. I just had to flip the terms around to make sure x squared came first. Okay?
It doesn't matter the order.
In this case, like in the very beginning, it does matter the order.
Why?
I'm sorry, that was not my question.
Okay, go ahead.
My question was, if you switched it, I get that we have to have the x squared first,
Mhm.
the formula, right?
Mhm.
Before we start, start working, right?
Yes.
That makes sense now. So it has to be in the x squared plus or minus number x, whatever, right?
Yes, it always is going to be some x squared, some x, and then just a number at the end. And the reason for that is because that allows us to identify A, B, and C.
Okay.
So if we were,
First thought
yeah.
that it would be negative 8x squared.
Oh, I see. Well,
Plus 2x. Does that make sense?
so we carry the sign that's attached to it. So this plus sign is attached to the 8x squared. That's why it's positive.
Okay.
Okay, so whatever sign is in front when you're moving it around has to come with it.
Because technically it wasn't tampered with.
Yes, yes. So if you change it up like that and you're trying to change the sign with it, then you're manipulating the equation.
Right.
Versus what we're doing is just reordering it.
Okay.
Okay, so yes, we do need to make sure it's in this form so we can easily identify our A, B, and C. And remember, whatever sign is in front of it is going to belong with our A, B, and C. So B is -2 and C is -3. Okay. What's our next step? A times C. And what is A times C? -24. So -24. So two numbers that multiply to that, but add to -2. Okay. So remember, we start writing our factors. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's the last one. Okay, and then of course, since it's negative, either one of those terms can be negative. Okay, so it could be a -1 and a positive 24. Good, or it could be 1 on the bottom. So on the bottom, like they're saying, is 4 and 6. So which one would have to be negative
6.
to add it to 2? Good, 6.
So you could be strategic because, like, technically you can keep going down until you get the same thing.
Yes, you could. You could just keep, you could go through every single one if you wanted to find which one would add up. But by looking, we know, okay, if we were to move around 6 and 4, since they're so close to each other, that's more likely to give us a -2. Okay. Just like if I'm looking at this one, this is likely to give me like a 5. Okay, or this one a 10. Okay. So then from here, we're going to take and we're going to expand this. So it's going to be 8x squared plus 4x minus 6x minus 3. Because remember, we wanted a positive 4 and a -6, so it would match up with our -2. Okay. Then we put the parentheses. And then what's our next step? GCF, good. Of 4x, yes, 4x. Okay, 4 because we can take 4 from 8 and 4. And then x because one has 2 x's and the other has just 1 x, so 4x. What's left over in the parentheses? 2x plus 1. Good, so if we want the next parentheses to have a 2x plus 1, what is our GCF we're taking out of that one? -3. So we can have 2x plus 1. So which means we have 2x plus 1 as our answer and 4x minus 3. Okay. Okay, go ahead and take a minute and try this one. Once you have your answer, compare with your neighbor. Okay, so this one definitely involves the calculator because when we multiply our A times C, what number did you guys get?
36. It has to be plus, right? It has to be like A plus C equals B.
Or they could both be negative if our B was negative. Yes, but since they're both positive, yes, it had to be plus.
What I mean by is like a refactoring of A plus C, the answer
Mhm.
A plus C.
Mhm.
We factor that in order to find, we use the numbers for factoring to add it up to our B.
Yes. So, yes, in this case, they would both have to be added, both positive. Oops, A, B, C. So, you guys got A times C, which was 36. And then you are trying to find two of those factors that add up to B, which is 13. Okay, so we had 1 times 36, 2 times 18. 2 times 18. And then 3 times 12. 4 times 9. Good. And then I think the last one is 6 times 6.
Yes.
Yes. Okay. So then which of these would add up to 13? 4 and 9. So those would be the only ones that if we were to add these give us 13. Okay, so then I go ahead and plug these in. So 6w squared plus 4w plus 9w plus 6. Okay, so the very first thing that you guys should have done was, of course, put it in order. So I moved it to be 6w squared plus 13w plus 6. We multiplied our A times C to get 36 and found that 4 and 9, when we add them, will give us 13. Okay, so what's our next step from here? And then take the GCF. Good. So what's the GCF for the first one? 2w. So then I'm left with what? 3w plus 2. Which means my next parenthesis should also be 3w plus 2. So what's the GCF that I'm taking out? A 3. So I have 3w plus 2. Which means I take one of those parentheses and bring it down, and then my other parenthesis will be 2w plus 3, and that is my answer.
How come we couldn't put the 9 with the 6?
You could have. You mean like switch these?
Yes.
Yes, you could have done that, and the only difference is you would have got 2w plus 3 inside the parentheses and 3w plus 2 outside. So it would end up with the same thing, just the order of the parentheses change. Yep, you can put it in any order you want. Okay.
When you write out your answer,
Yes.
say, in this case, Alex, it's going to consider correct if it's either way.
Correct.
Just like if it was like homework 1, we had less than or greater than, it's both, it equals to it.
Yes, yes. And if it happened to mark it wrong and it was right, if you just send me an email, I'll go into Alex and mark it right for you.
Okay.
But it should not mark it wrong because it's the same thing. The only thing I can think is like it's very, and I'm sure you guys noticed by now, it's very like finicky. So like if you have an extra space in there, it will mark it wrong. So it's just make sure you're putting everything exactly how you have it written. Okay. So the next one now is not only do we need to check that everything's in order, we now need to see if we need to take out a GCF before we even begin. Okay, so can we take a GCF out from each of these? 5 and an x. Because remember, the goal is to factor a trinomial, and a trinomial has x squared, then x, then a number. We are not going to talk about how to factor a cubic here. So you know you have to also take out an x. So 5x, so when I take out that 5x, I have to write what I have left over. So what would be left over from 10x cubed?
5x squared.
Is it 2 or is it 5?
2x.
2, remember, because we're dividing. So 10 divided by 5, so 2x squared. Okay, and then what would be the next one? Negative 17, everyone agree?
Yes.
Negative 17x, perfect. And then from the last one? Positive 21. Okay, good. So now that we took out that GCF, it looks like a quadratic equation that we can go ahead and start factoring, just like we've been. So I'm going to label my A, B, and C. And we're going to ignore that GCF for now, and we're just going to bring it back when we write our answer at the end. Okay? So I do A times C, which would be what? 4? Oh, sorry. Yeah, 42.
Quick question.
Yes.
I'll ask this after we finish. No worries.
Okay. 42, yes. So 2 times 21, 42, and then that has to add to negative 17. So then we think of all of the factors of 42. So we know it's 1 times 42, 2 times 21, 3 times 14. Do we need to continue? No, because 3 and 14, I know will add to a positive 17. Yes.
Could you give both of them negative stat?
Perfect, yes. You would want both of them negative in order to add to that negative 17. So this is negative 3 plus negative 14. And again, the reason for that is a negative times a negative gives us a positive. So it's okay that they're both negative. We still multiply to our 42, and now we add to our negative 17. So then expanding this, there'll be 2x squared minus 3x minus 14x plus 21. Again, it doesn't matter the order you put this in. You could have done minus 14x first, and you'd still get the same answer. Okay, so then I put it in my parentheses and take out a GCF again. So what GCF can I take from the first?
X.
Good, just x. And I'm left with what? 2x minus 3. So I'm taking that x away. So 2x minus 3, which means I want to have that in my next parentheses. So what GCF can I take out? Negative 7. Why a negative 7 and not a positive 7?
Negative 14.
Good, because we want a positive 2x in the parentheses. So 2x minus 3. Remember, we always want these to match up. Okay, so if we would have just took out a positive 7, then we would be left with a negative 2x plus 3, which is not the same thing as 2x minus 3. Okay, so then I bring down the 2x minus 3, and what's my other parentheses? X minus 7, and what can I forget in the beginning? That 5x. I have to bring that all the way down, and then this entire thing is my answer. So, yeah, don't forget about the GCF.
That's what I was gonna ask
Okay, about the 5x?
Yes.
Yes. We forget about it for now, and then we bring it back at the end.
That makes a lot of sense.
Yes.
I was like, we can't just throw the 5x away. Like,
No, we can't. It has to be part of the
I was
problem.
like,
Yes.
Did we simplify? We did simplify, but we know it's times 5x.
Yes. So we simplified it so we could factor it, but then we got to bring it back. Yeah. We couldn't just forget about it completely.
That makes sense because of the GCF. It's the GCF of the original.
Yes. Yes. Okay. Okay, go ahead and take a minute and try this one. It's going to be like the one we just did, which means you need to take out a GCF first.
Question real quick.
Mhm.
Does the GCF have to include a number, or could it just be,
It doesn't have to include a number, but this one can include a number. Mhm. But it is possible to just take out a GCF of just a variable. So yes, that is possible.
Just G1. Well, GCF means greatest common function. You can't divide 9 by 6 because you can divide 30 by 6. You can divide 4 by 6. So 3 is something you can divide 9 by 6.
Okay. So what did you guys get for the GCF? 3y. Good. 3y. So 3 because 3 can divide into 9, 30, and 24, and they each have a y. So when we do that, what's left over? 3y squared minus 10y plus 8. Perfect. Okay, and then from here, we're identifying our A, B, and C. Okay, remember I do that line to indicate we don't want to forget about that negative. Okay, and then we do A times C. Good. Yes, 24. So two numbers that multiply to 24 but add to negative 10. Okay, so remember we write down all of them if we can't recall. 3 times 8, 4 times 6. Okay. And so just by looking at those, there's 2 of them that almost looks like they could work. The 2 and the 12 and the 4 and the 6. But which are the 2 actual ones?
The 4 and the 6.
The 4 and the 6, but can they be positive?
No, negative.
They both have to be negative. Good, so -4 plus -6. Okay, that adds to -10, and then a negative times a negative is a positive, so it multiplies to 24. Okay, so I'm forgetting about my GCF right now. I'll come back to it. And I have 3y squared minus 4y minus 6y plus 8. So I exchanged the -10y for -4y and -6y.
Why wouldn't you make it 3y squared minus 6y minus 4y?
You can. And if that's what you did, I'm sure your answer is also correct.
Right.
So it's more of preference. Okay? So sometimes I'm like, okay, I'm just going to put them in order that I write them. And then other times I'm going to say, okay, well, yes, it makes more sense to have a 3 next to a 6.
That's what I had
Mhm.
originally put it as -4x plus or minus -6x. But then I caught myself because you had said.
But again, we're going to get the same answer at the end. So it's just based off whatever you like to do. Okay? So then when I separate these and I take out my GCF, what would be the GCF I could take out of the first one? Y. Good. And so then I'm left with -4. Good. 3y because I took away one of their y's. And then -4 because when I take away the y, I'm only left with that -4. Okay? Which means what should I take away, or what should be the GCF of the next one in order for them to match? -2. So I'm left with 3y minus 4. Okay? So again, if you were to have flipped it and you did -6y first, the only difference is you would have get y minus 2 inside the parentheses, which is correct. Okay? So that means I have 3y minus 4, and then what's my other parenthesis? Y minus 2, and then what can't I forget? The 3y. So that is my answer. Never forget our buddy from the beginning.
I have a question.
Yes.
So I picked 2 different numbers, but I got the same answer. Just split.
What do you mean flipped? Like this parenthesis came first?
Yeah.
That's still correct. Yep. The order of the parentheses don't matter because we're multiplying. Why did I do 2 and 12? That's a great question. Okay. So let's say I did 2 and 12. What would have to be negative to get a -10? -12, right? But what's 2 times -12? Is that still positive 24? That's why. That's why. So it has to multiply to this and add to this.
That's why we can do negative, because if you multiply negative number by multiply negative number, that's also.
Is a positive. Yes.
I thought the
Yes.
rule that 68 is positive, they both have to be the same sign. That's why I was going with that.
Well, they are both the same sign. See, they're both negative. So they can both be negative and both be positive. If the C value is positive. But yeah, it brings back to that the negative times a negative is a positive, and a positive times a positive is a positive. Okay. Okay, so now we have one that has our extra variable in there. And remember I said the easiest way to think of this is to ignore that second variable. So I'm going to ignore the y's for now. Doesn't mean they're gone, I'm just ignoring them. Okay? So when I do that, really all I'm looking at is negative 18x squared plus 21x plus 15. So before I factor this, I need to first ask myself, can I take out a GCF?
Yes.
Yes, what would that GCF be? Okay, 3 would work, but typically we don't like negatives in the front. So let's take out a negative 3 to resolve that problem. So negative 3, which means I'm left with 6x squared, good,
Plus 7
Don't want?
minus 7x
minus 5.
minus 5. Yes, I don't want the negative in the front of the x squared. Yes, I never want a negative in front of there. And it's not saying it's impossible to do, but when you go into college algebra, they're going to start telling you, we don't want a negative there. So might as well start getting used to it now. Okay, no, the a value should not be negative. When our a value is negative, what happens is sometimes we may forget to, when we multiply a times c, to bring that negative. And then also when a is negative, if you remember those rules we learned yesterday about like if our c value is positive, then both our terms have to have the same sign, etc. Though they no longer apply when we have a negative a value. So if we can, we want to get rid of it. Okay, and get rid of it by taking it out with the GCF. Okay. So then if we're looking at this, A, B, and C, okay,
Negative 30.
good, it would be negative 30 is our A times C, and then what is our B value?
Negative 7.
Negative 7. So we need two numbers that multiply to negative 30 but add to negative 7. So let's first just write down some factors. So 1 times 30, 2 times 15, 3 times 10.
Yeah, 3 times.
Good, and I'm going to stop there because 3 and 10 work. What would have to be negative?
10.
The 10. So a positive 3 plus a negative 10 will give us negative 7, and when we multiply, we'll get negative 30. Okay, so I have 6x squared plus 3x minus 10x minus 5. Okay, put the parentheses around each of them and then take out a GCF. So what would be the GCF of the first one? 3x. Good. 3 because it can go into 6 and 3, and x because they both have an x. So what's left over? 2x plus 1, which means what do we need to take out of the next parenthesis? Negative 5, right? Because we want to have 2x plus 1. Okay. So then that means we had 2x plus 1, and I'm going to leave a little gap right here. Okay, and then we also had 3x minus 5, leave a little gap at the end. Why am I leaving those gaps at the end? For the y's, remember we crossed off those y's in the very beginning and I said forget about them now, but we're going to bring them back. They're going to go to the end of those parentheses. Okay.
One of the y's is squared.
Correct. One of the y's is squared. And you notice that also the x is squared, but we don't write x squared in our parentheses. Why would that be? Good. So when we check, remember we did the FOIL method the other day to check to see if I got our answer correct. We're going to end up doing x times x, which gives us x squared, and y times y, which gives us y squared. And then there's one more thing that we're missing from our answer. The negative 3 GCF, because we can't forget about that either. So can't forget about that or the y's that we crossed off. So that would be our answer. So let's look at the next one. Okay, so on this one, what would be my first step?
Ignore the second one.
Good. Ignore that second variable, in this case, the y's. We're going to cross those out. And then I'm just going to rewrite it without those y's. Okay. And then what else is in there that we don't typically like?
A negative.
A negative in front of the
X squared.
x squared. So that means we need to try to take out a GCF. And what GCF besides the negative can we take out? Negative 2. So then I'm left with 4x squared. What else? Plus 4x minus 15. Okay, so now I have my A, B, and C. Okay, so my A times my C, 60 or negative 60? Negative 60 because of that negative 15. And our B value is 4. So two numbers that multiply to negative 60 and add to 4. So I'm going to start writing down my factors. So 1 times 60, 2 times 30, 3 times 20. What we said 4 times 15. 5 and 12, thank you. 6 and 10, and then I'm going to stop there. Okay, I know I'm going to use 6 and 10 because if I make which one negative to get positive 4? 6. So this is negative 6 plus 10, which gives me a positive 4 when I add and a negative 60 when I multiply. Bless you. So then I have 4x squared minus 6x plus 10x minus 15. And then my next step. Good, do factor by grouping. So parentheses around the first and then the last two. And then I need to take out a GCF, and what would that be? 2x. Good. Always check if you can take out a number and a variable. So then what am I left with if I take out 2x?
X minus 3.
Close. 2x minus 3, right? 2x minus 3. Because you did 4 divided by 2 to get 2. And then, yes, negative 6 divided by 2 to get negative 3. Okay, which means we want the other one to match. So what am I taking out? The 5. So then I have 2x minus 3. Okay, so then when I write my parentheses, I'm going to write 2x minus 3y. And then in my next parentheses, I'm going to do 2x plus 5y. And then what do I have to bring down? GCF of negative 2.
I have a question.
Yes.
I didn't catch on the last problem, so I'll try to catch it. But, how is it that we place the y? Someone had said that y squared or something like that.
Yes, so we can do that. Let's go ahead on this one, do a check. And so we can see where the y squared and the x squared went. Okay, so remember, in order to check, we would FOIL everything together. Okay, so first I'm just going to FOIL the parentheses, and then I'll worry about the GCF at the very end. Okay. So these are the answers that I just got. Okay. So if I FOIL this, I multiply the first term into the second parentheses, and then I multiply the second term into the second parentheses, which means I get 2x times 2x, which is 4x squared, and then 2x times 5y, 10xy. Okay, then I'm on the blue arrows now. Negative 3y times 2x. Negative 6xy. Okay, and then negative 3y times 5y. Negative 15y squared. Okay, I can combine the middle terms because they're both x and y's. So I have 4x squared plus 4xy minus 15y squared. And then remember our GCF in the beginning. What was that GCF? Negative 2. So I'm going to multiply negative 2 in by distributing. And I get negative 8x squared, negative 8xy, and plus 30y squared, which should be our exact answer or our exact problem in the beginning, which it is.
Yeah.
So if you ever feel like your answer doesn't look right, you can go back and check. And if you get your original equation back, then you did your math correctly. Okay. So that shows that yes, the x squared and the y squared don't disappear, they're there. We just factored them out into its simplest form. Okay. Okay, and then we end up with something like this. Okay, 2x to the fourth plus 5x squared plus 2. Okay,
GCF would be x squared.
so it's a good thought, but the 2 at the very end doesn't have an x squared, so I can't take out an x squared. Can I take out just an x? Does the 2 have an x? No. Can I take out a number?
No. Because 5.
I can't take out a number because it's 2, 5, and 2.
Can you give an x to the 2 so that you can divide them all?
But then I would manipulate the problem and change the equation if I gave it an x. So what this is called, what we're going to do is called U substitution. Okay? So if you can't take out a GCF, from the variables or from the numbers, and you end up with something that looks like x to the fourth and x squared, you know you're going to be using U substitution. And that's exactly what it means. We are going to replace our x's with u's. And what I mean by that is I know that in a typical quadratic equation, it should be ax squared plus bx plus c. So I know I should only have one variable next to the b, and that should just be only an x. So I'm going to let u equal x squared. Okay, so it's always going to be that middle term, always. Which means, what happens if I square the u? That means that's x squared squared, which is x to the fourth. So that means instead of writing this with x's, let me substitute with u's. So this is 2u squared plus 5u plus 2. Now are we able to factor this? Yes, because now it looks like a quadratic equation, just like the one I drew in purple above. Okay. So we're going to go ahead and go through our same process. So this is A, B, and C. So A times C would give us 4. And then our B value is 5. So what are 2 factors of 4 that would add to 5? 1 times 4, good, because 1 plus 4 is 5. So then I would write 2u squared plus 1u, or I just write u, okay, plus 4u plus 2. Okay. We do the same thing. We do the parentheses. And we take out a GCF. What GCF can come out of the first one? U. So I'm left with 2u plus 1. And then what can come out of the next one? 2. So I'm left with 2u plus 1, which means I have the answer of 2u plus 1 times, what's my other parentheses? U plus 2. Okay, so even though this is my answer because it's factored, was my original equation in terms of u? No, what did we let u equal? X squared. So I'm going to replace all the u's with x squared. So 2x squared plus 1 and x squared plus 2. That is my answer. Because I substituted u equals x squared back in. This is what makes math so fun.
That's so cool. So
I think it's awesome.
So like the U basically like makes doesn't give you a headache, basically, right?
Correct. You could have solved this with all those x's, but you might end up losing an x in the process or getting all confused. And so, yeah, U substitution is the easiest. Okay.
And that happens when?
You know you're using U substitution if you see x to the 4th, x squared in those spots. And you're not able to take out any GCF at all. Okay, so typically that last term is going to be just a number, which means you can't take anything else out with it. Okay. Go ahead and try that last one. I believe this is the last one. Yep. Okay, so it's going to be the same process. You're using U substitution because we see y to the 4th and y squared. That's how you know you're using U substitution.
After that, it's exactly the same, right?
Correct. Just don't forget to plug in your U back in. Yes. Do you want to check if you got it? We're about to go over it, so go ahead and tell me what did you get? Okay, so let's go ahead and check because I don't have it memorized, the key. So it sounds right though. The only thing is it going to be in terms of x or is it going to be in terms of y at the very end, right? Because it's y to the fourth and y squared at the very end. At the beginning, we're going to have it in terms of u. So we're going to say let u equal y squared, right? Just the variable, right? Just the variable. Which means that u squared is going to equal to y squared squared, which is y to the fourth. Okay, so then I plug in those values. I have 3u squared plus 2u minus 8. And then I solve like normal. So this is my a, b, and c. And what is a times c? Negative 24. And my b value? 2. So I'm going to write all the terms that multiply to 24. So that's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I'm going to stop there. And which one is going to be negative? 4, right? Negative 4 plus 6 is going to give me a positive 2. And if I multiply them together, it gives me a negative 24. So I have 3u squared. And let's do it this way where I put the one that seems to work well with that 3, which would be 6. So I'm going to do plus 6u minus 4u minus 8. You don't have to do it that way. I don't want you to erase your work if you did it the other way because you're going to end up with that same answer. Okay? And then you do your parentheses and take out a GCF. What would be the GCF of my first parenthesis? 3u. So I'd be left with u plus 2. And then what would I have to take out of this one to get u plus 2? If I take out a 2, I'm still left with a 2u. So take out a negative 4 because I want u plus 2 in that parentheses. Okay, because negative 4u divided by negative 4 would give me just u. And negative 8 divided by negative 4 would give me a positive 2. So that means I have u plus 2 times 3u minus 4. But I know u was equal to what? Y squared. So I actually have y squared plus 2 times 3y squared minus 4, which is my answer. Which it sounded like the one that you had in the beginning, what you said in the beginning.